Managed Mentoring Guide for Getting Started in Beekeeping. Sourcing and building frames as well as principles of foundation. I am Kevin England. Welcome to Building Frames. There's a lot of ground to cover here, and in this lesson we will review the basics of frame offerings, a primer on frame designs, sizes, and foundation offerings, instructions for frame fabrication, drone brewed frames, and we'll finish a lesson with a short aside about foundationless frames. Let's get started with what is the heart of the hive, honeybee frames. Frames serve as the home for the bees. The entire life of a bee, except for the time spent outside of the hive for foragers, is spent in the hive and on the comb within the frames. Fundamentally, the primary design of a honeybee frame for a Langstroth hive is based upon the Hoffman-style frame, which was developed in the late 1800s by Julius Hoffman of Fort Plain, New York. The Hoffman-style frame is designed with specific measurement dimensions, and for the Langstroth hive, they come in three standards. The top bar length is a universal 19 inches. As the diagram shows, the deep, medium, and shallow frames are 9 1/8, 6 1/4, and 5 3/8 inches deep. These are the key parameters in which the industry has standardized on, and they should be consistent across all of the manufacturers. When it comes to the hexagon sheets that occupy the space of the frame interior, the substrates vary. Beekeeping equipment providers have experimented with a wider range of substrates over the years. Wax-coated plastic, plain sheets of wax, all plastic frames with full-depth cells, and other choices have been offered at times. Modern frames these days are dominated by two forms: wooden frames with plastic foundation, which is often supplied with a coating of wax at the factory, and wax sheet foundation with embedded wires that provide rigidity and stability for hive work and for use in honey centrifuge machines called extractors. Now, you can buy just plain wax sheets with no wires, but most sold in catalogs these days are the embedded crimp wire style, like what's pictured on the slide. The embedded wires are physically crimped in a machine to make them wavy, and then they are pressed into the wax. The wavy design gives rigidity to the wax sheets and may also help increase the surface area for the embedding process during manufacturing. As shared in the last lesson, wax is the more traditional choice, but nowadays plastic is a popular option due to its ease of use and durability. Most beekeepers use wooden substrate frames, but as you can see by the photos, there are frames manufactured made entirely of 100% food-grade plastic. One unique example is the Flowhive frame, pictured in the bottom right, which comes with fully drawn-out cells and has some special engineering for the purpose of honey harvesting without uncapping built into the frame substructure. It is evident by the black plastic frame pictured here that it has a coating of wax. How much wax applied to the surface is often a consideration for beekeepers. As mentioned in the last lesson, some of the beekeepers like a light coating and others want a heavy application of wax. There are different schools of thought as to which is better and why, but by our experience, most beekeepers would favor more wax and profess that it's better for adoption by the bees, and we tend to agree. The dimensions of the frame construction might be standard, but the physical construction and attributes of frame design varies in the marketplace. As you can see, depicted are 3 variations of top bar designs and 4 variations of bottom bar designs. If you do further research, the ones depicted are the most common, but there are even more styles offered out there in the marketplace. One thing to know about beekeeping equipment is that someone is often coming up with alternative designs on the premise that this new design is going to be superior in some way. The selling point of the slot top bar design might have been that you slide the foundation in instead of using a traditional wedge. The design variations often play into what wax foundation style is used with the frames. Most beekeeping companies have one design for frames that hold plastic foundation and multiple designs for frames that hold wax foundation. This can be confusing, but we will tell you in the next slide which frame to purchase for wax foundation and why. As the slide says, you have to make a choice between wooden frames with either plastic or wax foundation. On this slide, we're going to answer the question about what design to choose for wax foundation frames. The style is a combination of a wedge top bar and a groove bottom bar. The frame on the lower right shows how the wedge, or it's sometimes called a cleat, is used to hold the wire tabs that are at the top of the crimped wires. This cleat design element of a wedge frame is what secures the foundation in the frame. The foundation itself, the wax sheet, is a touch flexible, and when it comes to putting it in the bottom groove, it's curled temporarily so the bottom edge can be lifted up over the edge of the groove and slipped into the slot of the bottom bar. There is one design when it comes to choosing your frame styles we want you to stay away from, and that is the slotted bottom bar. This is the underside of a box that has slotted bottom bars for frames. It's tilted up in this photo, and you can see that the bees will look to fill any of the slots they find with wax and propolis. Not only do they fill the slots, they have a penchant for building errant comb on the bottom of these slots and even connect it to the top frames that are sitting in the box underneath. This becomes a really serious headache. Please follow our guidance to avoid other types of frames and you'll avoid the problems. So wedge style top bar and groove style bottom bar is what we recommend. Now, we said the frame dimensions are universal, but we need to talk about frame designs and how they differ from manufacturer to manufacturer. There is one dimension in the frame design that's fairly universal, and that is that the ear of the frame protrudes 5/8 of an inch from the sidebar as depicted in the upper right corner of the slide. As you can see, though, by the illustrations, the physical shape and design of the bars are left to manufacturer discretion. Again, different designs have emerged over the years with different shapes and rationale as to why one is better than another. These shapes are often not that critical, but they do impact how the frames hang in the hive. As to the thickness, we do have a preference that the thickness matters and recommend the more substantial half-inch design. Together, the boxes and the frames work as a system, and in the next few slides, we'll examine that more closely. Woodenware box ends have an engineered slot called a rabbet for frames to rest in. The ears of the frame make contact with the rabbet as it hangs in the hive box. Manufacturers have standard box dimensions to adhere to, but like the frame design ends, they also have the liberty to choose the depth and width of the frame rest rabbets. What the illustration on the right shows is that almost universally, companies have standardized on the depth of the rabbet to be 3/8 of an inch. This is not a concern when looking at what manufacturers do. However, when it comes to the width of the rabbets, unfortunately, it is not universal and vary from manufacturer to manufacturer. Most in the marketplace have settled on 5/8, but some have landed on 3/4. Stop for a moment and think about this. Does the difference matter? If you answered yes, you are right. It has to do with bee space. And a picture is worth 1,000 words. This is a real-world example. You purchase your kit from vendor X, and you purchase the compatible frames to go along with it. You source your bees from a nuke provider and they use vendor Y. The dimensions for the frames in the nuke may not be the same as the ones you are using, and it's going to cause problems down the road. It has to do with how the frames hang in the box. If the frames from vendor Y were not good in your box, then at some point when you move them to the top, you can have gap problems like what's depicted here. Now there's a simple solution to this in the beginning. You keep your nuke frames on the bottom over the bottom board, which is more forgiving from a space standpoint. When you bought your kit, you purchased 20 frames, and in time, you're going to rotate in your 5 frames and rotate out the nuke frames that you got from someone else. Now we'll talk about rotating out old comb in upcoming lessons, so we're not going to cover that here, but you do have to know that this problem exists and you need to find a solution to prevent problems down the road. We have one more tip about this coming up in a few slides, but for now we want to give you some similar advice for buying foundation. This frame shows wax foundation, and what is being shared applies to wax, but it also applies to plastic. Make sure that you buy the foundation 100% compatible with the frame design. As you can see by the slide content, the depth of the foundation sold for various frame designs is tailored to go with the frame style. If you get it wrong, you're going to have some serious problems. Kind of like this. This is exaggerated for illustrative purposes, but if your foundation is too long, it bows out like this. And it's an evil job to try and correct the situation for 40 sheets or more. Incidentally, if this does happen by accident, talk to us, and we'll give you some instructions on how to correct the foundation that's too long. If you ordered foundation that's on the short side, there's not much you can do about that, but let it hang and wait for the bees to affix it when they build out their comb. The point here is take your time when selecting your frame design to ensure that you get the matching foundation that's compatible with it, and you'll keep yourself out of trouble. Let's move on to fabrication. This illustration tells you the basics of fabricating a frame. When it comes to where to nail the frame, where to glue the frame, and explicit instructions for how many nails to use. As they say, the devil's in the details here, and if you get it wrong, your frames could fall apart when you're prying against them with your hive tool, leading to bees spilling out all over the place. Now there's one other thing to note, and it's covered in a previous lesson. The foundation is held into the sidebars in 4 places. This illustration shows 2 options, the pin we recommended previously, and the use of a bobby pin if you want to go old school. Please remember to order the nails and pins for building frames from the manufacturer when you're placing your order, and there'll be a touch more about that in a few slides. Some say gluing your frame is optional. We say to you it is not. Make sure you use a good quality wood glue and glue all of the spots shown in all 4 corners. Glue works best when applied with an even coating, and to say that another way, flooding the spot where you glue is not the right way to go. This slide shows places to put the nails. 2 for the top bar on both ends for a total of 4. 2 for the bottom bar, again on both ends, and a total of 4. 2 that go sideways into the top bar to anchor it so it doesn't get pulled out. And that's a total of 10 nails per frame, not including the wedge cleat nails. A quick aside, there are 2 ways to set the side nail. You can go through the ear of the sidebar at the top and into the top bar, through to the other ear on the other side. Or you can go under the bottom sidebar of the ear, through the sidebar and into the bottom edge of the top bar behind it. This is the nail shown in the center blow-up of the illustrations on the slide. Let's show you one more visual of this. The one on the left shows the nail going through the ears as described, and the one on the right goes into the sidebar and through into the top bar behind it. Either one of these methods will do, but truth be told, the nail through the end bar is a bit hard to do, and unless you have a really small hammer to hammer underneath that end bar, do the one through the ears. What about nail guns and staples? If you have the woodworking acumen and the pneumatic equipment, it's a good way to go. Be sure to source the right staples, and it would still require a side staple like what is shown here. This method saves times, but sometimes it can be a hassle if you don't have the air pressures set right. Now, if you know, then you know what we're talking about. A real time saver that everyone can use is on our next slide. This is a frame jig, and after you have used one, you will loathe any prospect of having to build individual frames one at a time. They hold the frames in place so you don't have to. The frames are square in the jig, and you do not end up with frames that are misshapen by accident. You can buy one in most catalogs, or if you are the least bit handy, they are easy to build. There are plans on the internet for these, and we provide some in the resource section for this lesson at the Managed Mentoring website with the presentation. Start by running a bead of glue along the flat edges. We like to use a coffee stirrer stick to smooth out the glue. Using the stirring stick or your finger, bring the glue up the inside edges of the ears that stick up for the best contact with the top bars. Around us, there are two primary brands of wood glue that are commonly sold in the stores, Titebond and Elmer's. To my recollection, it's not a requirement for these to be exterior grade glues. Titebond 3 is often recommended as a superior product in the line. Both of these brands are claimed to be non-toxic and okay to use in beehives. Insert the bars after gluing, tap the nails to set them, and then lightly drive them the remainder of the way. As noted earlier, buy your nails from the manufacturers who sell you the frames. Now, if you happen to have nails at your home already and you care to skip that guidance, then there's a reference here to the recommended nails to use for constructing frames. This is a bit of guidance on how to approach nailing frames if you're not familiar with nailing things together. In time, you will develop a feel to set the point of the nail so the nail is in the wood and it stays put for driving the remainder of the way. When it is set, you can focus on driving it until it is fully flush and sunken into the wood. For holding small size nails, consider the rubber band tip shown on the slide with a pair of needle nose pliers. When it comes to hammer choice, choose a moderate sized hammer for the smaller nails used in building frames. Now flip the jig over and appreciate that the jig keeps all the frames held tight and organized so you can work on the bottom side. Glue the bottoms of the side bars in the same manner as the top ones. Once they're glued, tap in the bottom nails. Pull out each of the frames from the jig and finish with the side nail. One thing to keep in mind when driving the side nail is that there are nails holding the top bars to the side bars and you need to avoid those. Keeping that in mind, you may have to slip the side nail forward or back in order to make sure it does not hit the nail securing the top bar. We did not tell you about the pre-built option because honestly, we kind of want you to earn the rite of passage of building your own frames. Nowadays, you can pay an upcharge and buy pre-built frames. Building frames is a time-consuming task, but one thing we'll say about pre-built frames is the manufacturers use staples and they construct their frames differently than the process we just covered. On rare occasions, we have encountered failures with pre-built frames pulling apart. There's something about the staples and the fact that they seem to work themselves free over a really long period of time. Now, periodically something pulls apart while prying on the frames, and, well, it's not something you see rarely, but it's hard to get it back together because the staples don't tap back in. It is rare, but it happens, and call us weird, but there's something cathartic about knowing you built your own frames. This practice identifies without question which manufacturer made the frames that are in service. Now, someday when it's time to replace the foundation, you'll know which manufacturer to go back to source the right size foundation. And if you need additional frames in your enterprise, you can buy this from the same manufacturer. This is a drone brood frame, all plastic, and by convention they are green in color. The purpose of this device is for luring varroa mites into the drone brood area. Once they are there, you subsequently cull the whole frame of bees, thus dispatching any mites that are also in the cells with the bees. Using these is a year 2 instruction in our program, and we'll come back to their usage at a later time. For now, we're just covering them so you know that they're out there and we did not miss them. This is an ingenious invention and a relatively new item in the marketplace. To our knowledge, this solution, which originated in Europe, is only offered by the Better Bee Company in the United States. To see one is to see a perfectly drawn comb of wax. Our recommendation is, as tempting as this seems, we do not want you to use these. We've had beekeepers try them, and they did not hold up, and we do not want you to be encountering problems. In some instances, we know that the comb turned soft and sagged when exposed to the hive conditions. There's also some beekeeper impressions about the implications of using wax that's not pure beeswax, but no commentary on that from us right now. Our guidance is in a few years when you have a good handle on things, if you want to try them, be our guest. But as part of our program, we would recommend you stay with the formats where the bees build out the honeycomb and avoid any potential problems that could trip you up. This is another management approach that exists, and we'll take a moment to tell you about it, but ask you to refrain from considering it in this program. This is the concept of giving bees a full frame bar that has no foundation sheet. A top bar is manufactured with a built-in guide like the one depicted here. Sometimes, in use, beekeepers hang a partial starter strip in lieu of using a guide, a different format top bar. Both are intended to coax the bees to build honeycomb down to the bottom bar without any foundation. In principle, they work well, and truthfully, they are a good choice, but for an experienced beekeeper. In practice, they can be complicated and require some skills to master. Sometimes the bees do not build proper comb on them, and being that is true, we don't want you to struggle with that. Also consider that there are no wires to support the drawn comb, requiring some skill in handling because it's easy to break the comb, especially when they're brand new. Like the other guidance, please wait until you are a little further along in your skills before considering using these, and we will cover them later in the program. This closes out this presentation. In our next lesson, we will give a primer on how to fabricate hive boxes. We're going to follow that with painting hives, sourcing bees, and some ins and outs of packages and nukes. If you have any questions, you can ask at our next online session, and you can also send an email to the address on the slide. If you're watching from YouTube, you can leave a comment below. If you're not watching from YouTube, note that you can hover over the video, click on the YouTube link that presents, and go to YouTube directly. If you're there, please take a moment to subscribe to the channel. Thanks for watching, and we'll see you in the next lesson.